Okay.
and speed.
What sort of research are you doing at the Institute?
Well, there are many people, researchers working here at the Institute, and I work here too. I work along a number of different lines. I've been interested in superconductivity, substances that carry an electric current without any loss of energy because of resistance, and various other scientific problems, some of which have practical applications. I also spend part of my time together with the other people, most of the other people here in this institute, working on health and disease, trying to get better control of diseases that cause suffering to people, especially diseases that cause people to die young instead of living out their lifespan as one might expect, living to age 75, or I say now living to age 100 or 110 or 115. I believe that it's possible for us to make very great contributions to the prevention and treatment of disease and to slowing down the process of aging by making use especially of vitamins and other nutrients, which have been pretty largely neglected by most medical researchers.
Right, could you change size, Barry, please? You okay?
Mm-hmm.
How would vitamins help slowing down the aging process, and what sort of vitamins should one take to do it?
A question that we have been working on and are working on, and we've been doing this for about 20 years now, is to what extent could the process of aging be slowed down and disease be prevented and controlled by taking larger amounts of various vitamins. I became interested in vitamin C, ascorbic acid or sodium ascorbate or calcium ascorbate, different forms of vitamin C, all of which have the same protective action, for 20 years, actually for about 25 years, but I began working hard on it 20 years ago. I myself take 300 times the recommended amount of vitamin C every day. And I've been taking this large amount, over half an ounce a day instead of just a tenth of a teaspoonful. I've been taking this large amount for many years now. I attribute my pretty good health to the vitamin C that I've been taking, also to other fortunate circumstances about my life. For example, that I got married in 1923 when I was 22 years old, and it was a very successful marriage. I got along very well with my wife. She helped to protect me against stresses of various sorts for 60 years about until her death. At any rate, vitamin C, I think, when used in the proper way, could slow down the process of aging more than any other step that we could take or know about at the present time. My estimate is that with the proper use of vitamin C, people could live 25 years, perhaps 35 years longer than they live at the present time.
Change size, Barry. Why does vitamin C appear to have such a dramatic effect on longevity?
Well, vitamin C is different from other vitamins in some very interesting ways. I think that we should be taking larger amounts of other vitamins too. but I know more about vitamin C and its effect on aging, slowing down aging, and protecting us from diseases of various sorts than I know about other vitamins. One difference between vitamin C and other vitamins is that you need large amounts of vitamin C. Even the recommended amount that the British and the American governments or pseudo-government groups, Food and Nutrition Board in the United States recommend, are much larger for vitamin C than for other vitamins, 10, 20, 50,000 times greater than for vitamin B12, for example. The reason for this is that other vitamins usually work to speed up certain chemical reactions in the body without being destroyed themselves. Vitamin C gets involved in all sorts of biochemical changes that take place in the human body, and it is destroyed when it takes part in these reactions. So you need to get a large amount in your diet in order that there will be enough vitamin C in your body for these chemical reactions to go on. One of these chemical reactions is producing a protein, collagen, something like gelatin, which is the protein that holds our bodies together, the substance that makes the blood vessels strong and the skin strong and the bones strong and the teeth strong. You can't make this substance without using up vitamin C. So your body is going to be weak in a structural sense if you don't take large amounts of vitamin C. The vitamin C works in producing this protein, collagen. It works in such a way as to make the blood vessels strong. When people used to die of scurvy, sailors sent out by the British on the naval ships or merchant marine ships, after 2 or 3 months of not getting fresh fruits and vegetables, the sailors would die of scurvy. And most of them died by internal bleeding. The blood vessels broke open because vitamin C was not there to strengthen the blood vessels. Another way in which vitamin C works is to keep fatty deposits from being laid down in the blood vessels. It is these fatty deposits, the cholesterol, usually called the cholesterol deposits, that are laid down in the arteries that are the main cause of heart disease. And of course, heart disease is the principal cause of death. Half the people in the United States and half the people in Britain who die of heart disease, and often at an early age, or 30 or 40 or 50, instead of living the standard average survival time after birth of about 75 years. So we need to have a large amount of vitamin C. Another way in which vitamin C differs from the other vitamins is that most animals don't need to have vitamin C in their food. They do need all of the other vitamins just the way human beings do, but they make their own vitamin C. So it isn't a vitamin for a cow and a horse and a dog and a cat and a pig and a rat and a mouse. And they make it. And the amount that they make, an animal my size, a goat for example, manufactures about the amount of vitamin C that I take every day. That's 200 or 300 times the amount that the government recommends for human beings. I remember talking with a scientist, a doctor who was one of the people who set the recommendations for Britons. He was a Scot. He said, I know that people would be healthier if they took larger amounts of vitamin C than the amounts that we recommend. I think he was recommending 30 milligrams a day, which is, as I say, 300th of the amount that I take every day. He was recommending that small amount. He said to recommend a larger amount would require a complete revolution in the eating habits of the British people. So his committee, the committee that he was a member of, was still recommending this small amount of vitamin C, which they said you could get in food, ordinary diet, if you include enough fruits and vegetables, even though he knew that larger amounts would put people in better health and cause them to live longer and not suffer so much.
How does vitamin C, I can understand that vitamin C could delay getting heart attacks, but how does vitamin C extend lifespan?
Well, we know that every time you go through a period when you are suffering from a disease, there's a shortening in your life expectancy. This was pointed out by a scientist that I knew, a biostatistician who was at the University of California about 35, 40 years ago as the head of the Donner Laboratory of Medical Research. And he gathered together the evidence. Suppose that a person has an attack of, let's say, nephritis, acute nephritis, blood in the urine, and then gets over it, survives, perhaps is treated, survives. How much effect does that have on his life expectancy? Well, this was the sort of question that this friend of mine, Hardin-Jones, Professor Hardin-Jones, asked and answered by studying the statistics. And he found that this shortens life expectancy by about 2 years. And if you have a severe attack of, say, even if you have a common cold, it may shorten life expectancy for a month or two. I don't remember what his results are for the common cold. But if you have cancer, and half the people who develop cancer survive and the other half die, if you have cancer and survive, then your life expectancy is shortened by several years. Professor Jones said, perhaps when we are born with a certain store of vitality, and that every attack of disease that we recover from uses up some of that store of vitality, and then when it is exhausted, you die. Well, that's a rather simple theory of aging and death, that you're born with a certain amount of vitality, and that if you want to live a long time, you should be careful not to use it up. Stress uses up this vitality. There have been several contributions to the understanding of aging. A professor in the United States, Denham Harmon, about 40 years ago suggested that free radicals, chemical substances called free radicals, are responsible in large part for aging. And a free radical is a molecule that has had an electron knocked off of it so that it has a positive charge and its combining power is changed. It has the ability to hook onto other molecules in the body. If it hooks onto a molecule of cholesterol, it can cause the cholesterol then to be oxidized and have a greater probability of being laid down in the coronary artery in the heart and causing heart disease. This free radical theory is one that my associate Dr. Fleming and people working with him have been studying in this institute. One interesting fact about these free radicals is that vitamin C and also vitamin E, fat-soluble vitamin E, both destroy free radicals. A high intake of vitamin C and a high intake of vitamin E will help to slow down aging by destroying free radicals as fast as they're formed, or we hope that they are destroyed as fast as we are formed. These free radicals are produced in the body by certain chemicals, toxic substances that you get perhaps with your food or in the air, and by high energy radiation. If you are exposed to radioactivity, that does produce some free radicals in the body and may speed up the process of aging. And these vitamins that have antioxidant properties can destroy the free radicals and help to protect a person against disease. So this is a primary problem or group of problems that we have been working on here and continue to work on in this institute.
Change slides, bro. What, for someone who sees this program and decides they want to start taking vitamin C, what sort of dose would you recommend? And isn't it true that the ascorbic acid will burn the lining of the stomach taken in high doses?
No, ascorbic acid is a weak acid. It's about the same as vinegar, say, not a strong acid. You have a strong acid in the stomach, hydrochloric acid, so that ascorbic acid is not a strong enough acid to have an effect on the human body. And moreover, if you don't want to take ascorbic acid, you can take another form of vitamin C, a salt of ascorbic acid, sodium ascorbate, calcium ascorbate, magnesium ascorbate. Or if you were worried even about ascorbic acid, just taking a little baking soda will, it's an anti-acid, baking soda, sodium, hydrogen carbonate. So this isn't anything to worry about. In fact, ascorbic acid is one, or vitamin C, I'll say, not restrict myself to ascorbic acid. Vitamin C is one of the least toxic substances known. I knew a man who took 1/4 pound, 130 grams of vitamin C every day for many years, a decade. He had cancer, and he was supposed to die in a few months from the cancer, metastatic cancer in his brain and bones. He was also a chemist. He used to come in to see me every few months. And he was able to control this cancer for 13 years by this large amount of vitamin C. It didn't cause any problems from toxicity or any other problems. So you don't need to worry about the toxic effects of vitamin C. The one side effect that it has is that it acts as a laxative. Speeds up the motion of the waste products in the intestines so that you get rid of them sooner if you take enough. The amount that I take, 18 grams a day, 300 times the United States recommendation, this amount is the amount that has a laxative action for me. Well, this chemist suffering from cancer was able to take much more than this, nearly 10 times, about 6 times as much, because sick people, it is found, don't respond to the laxative effect of vitamin C the way well people do. This may be a way to allow you to take larger amounts of vitamin C if you are really sick and need to be taking very large amounts. Now, as to the question, if a person recognizes that he can slow down the process of aging and improve his health or her health by taking vitamin C, what should he or she do? You can buy 1 gram tablets. That's about 20 times, 25 times the British recommended amount. One of these 1 gram tablets does a lot of good, one a day of these 1 gram tablets. I usually carry them around in my pocket, and if during the day, I think I've used up all of my tablets, I'll have to put some more in my pocket. If during the day I feel sort of tired, I just take another of these 1 gram tablets. Well, 1 gram a day does a lot of good. It may not be enough to keep you from catching colds, unless you, at the first sign of a cold, take several, 2 or 3 an hour for a few hours to stop the cold. If you take 2 grams a day instead of 1 gram a day, you're in somewhat better health. Or if you take 4 grams a day, you're in still better health. Or if you take 8 grams a day, each time you double the dose, you get an added increment of good health. Well, I'd like to go up to more than my 18 grams a day, but the laxative effect prevents me from taking more. On the other hand, I think 18 grams a day is doing me a lot of good. Also, I recommend that you not buy high-priced vitamin C, a kind of vitamin C that the people who sell it, advertise it, say is better than other kinds. But look at the price. See how much you pay for a 1 gram tablet. You shouldn't pay more than 3 or 4 cents American pennies per 1 gram tablet. Similarly with other vitamins, don't buy high-priced ones because the vitamin seller says that these are better than the cheaper ones.
Do you believe that you should supplement the C with more antioxidant vitamins like beta-carotene and so forth?
Well, I recommend taking the antioxidants, but only the natural antioxidants, not taking drugs, hydroxytoluene, I've forgotten what. There are several antioxidants that are perhaps as effective as the vitamins, but they may have side effects, so I keep away from them. So beta-carotene is closely related to vitamin A. It's a precursor of vitamin A. When you take beta-carotene, it acts as an antioxidant. It also is converted into vitamin A and improves the eyesight and, in general, improves the health. The advantage to taking beta-carotene over vitamin A is that in large doses, vitamin A sometimes has side effects, not life-threatening, but some people get headaches if they take 20 or 30 times the recommended amount of vitamin A. So I recommend not taking more than 10 times the recommended amount, but take extra beta-carotene. Then you have vitamin E and vitamin C, also acting as antioxidants and contributing to better health and slowing down the aging process.
How far, if someone takes this regime, what sort of percentage could, or how many years could they add to their life? As a general rule, obviously.
The evidence is not complete about this because there haven't been enough people who have taken these large amounts of vitamin C for long periods of time. I've made a particular study of vitamin C and its effectiveness in increasing the span of life. I've already mentioned my estimate that I believe that a person who uses vitamin C in the proper way, starting early enough in life, can expect to live, at least on the average, 25 to 35 years longer than a person who just has the ordinary intake of vitamin C. How much additional improvement in health you can get with the other vitamins, I'm not sure. Actually, my analysis of the evidence led me to the conclusion that vitamin C alone can increase longevity by 25 years. And when I said perhaps 35 years, I was adding other vitamins, increased intake of other vitamins, and perhaps some other health practices, such as a moderate amount of exercise, or trying to avoid stress of various sorts.
If vitamin C is such a good vitamin to take, why doesn't the United States government tell everybody to go out and take 10 grams of vitamin C a day?
Well, probably for the same reason as, at least in part, for the same reason as this member of the British Committee on Vitamins who said to me, when he was visiting here in California, said to me that he knew that an increased intake of vitamin C led to better health, but that the committee couldn't recommend it because the British people couldn't get it in their food. They'd have to be doing something else. Then the rest of the reason is that there's a sort of bias on the part of the medical and nutritional authorities against vitamin tablets, vitamin supplements. I could never get the amount of vitamin C that I take by selecting foods. It would take 330 6-ounce glasses of orange juice a day to provide that much vitamin C. There's no way I could get this vitamin C except by taking vitamin C as a supplement. I don't take 18 1-gram tablets because I don't want to swallow this much. I buy it as the way you buy 5 pounds of sugar as a crystalline material. I buy pure crystalline vitamin C and take it by the spoonful, just dissolved in water, or perhaps in orange juice to improve the taste. So there is this bias.
So we're running out.
A little buzz action now.
Could you tell me about the amount of vitamin C that's excreted?
You know, there are a lot of statements made about vitamin C that just aren't true. Doctors are apt to make these statements that if you take more than a gram a day of vitamin C, it'll kill you, and just nonsense. Or that vitamin C will cause you to have kidney stones. This just isn't true, that large doses of vitamin C cause you to have kidney stones. And I remember 20 years ago or more, I read that the authorities say that it doesn't make good sense to take large doses of vitamin C because all of the excess over about 100 or 200 milligrams is immediately excreted in the urine. So you're just wasting your money. I decided that I should check that. I was taking 10 grams a day. I collected my urine for 24 hours and analyzed it for vitamin C, and I found I was losing about 1.5 grams in the urine. So the other 85% of it, 8.5 grams, was being put to presumably good use in my body. Even this 1.5 grams had value, of course, because it protected the urinary tract against infections. It's the way women often get bladder infections. Vitamin C in large doses will protect them, cure the bladder infections. Also helps prevent cancer of the bladder, cancer of the urinary tract. So there are a lot of statements made about the vitamins that just aren't true. I don't understand why the medical profession and the old-fashioned nutritionists, which means most of the people that are talking, that are authorities on nutrition now, continue to say you should search for vegetables and fruits and foods that contain large amounts of vitamins because to have an increased intake of vitamins improves your health. But don't take vitamin supplements. This just seems to me to be silly. Here, when discoveries are made, for the most part, people as a whole are glad to have them. When the first railroads were built, people in London didn't say, well, God didn't intend us to go to Manchester on a railroad train, so we'd better go by the horse and coach, taking 4 days and sleeping overnight to get to Manchester. They were glad to have the railroads to get there in a day. And similarly, when electric lights came in, we were glad. People didn't say, God didn't intend us to have electric lights. He wants us just to burn wax candles or something like that. But when vitamins were discovered, for some reason, when the vitamins became available at low prices, for some reasons these medical and nutritional authorities have failed to accept the idea that this was really a great discovery that the chemists were making around 60, 80, 100 years ago, that these substances exist, that we know how to make them or concentrate them from natural sources and make them available in tablets or as pure crystalline substances at a low price. I can't understand this, why they rejected this great discovery and continued to reject it by saying, be sure that you get certain amounts of each of the 4 foods so that you get enough vitamin C to keep you alive and enough vitamin A to keep you alive and so on. But don't take vitamin supplements, and especially don't take them in the tremendous amounts that fellow Linus Pauling recommends. I just don't understand it.
You said, if I can just take it back to, you said that a goat, something of your own body weight, like a goat, produces vitamin C themselves. But is there any proof that a goat lives longer because it does produce the vitamin C?
I didn't hear.
Oh, right. You said that a goat, for example, produces vitamin C. Is there any proof that a goat lives longer because it does produce vitamin C?
Well, I think I can say, I mentioned that a goat the size of a man manufactures approximately the amount of vitamin C every day that I take, 200 or 300 times the amount that the Food and Nutrition Board recommends for human beings. And I think that the goat isn't enough different from human beings the goat and the cow and the horse and the cat and the rat and the dog and so on, all of them manufacture these very large amounts of vitamin C. Why does the goat make only the amount that it makes? Why not make half that amount, which would still be 100 or 150 times the amount that human beings get, and save all of the energy and materials that it is expending in making this large amount? And why do goats continue to make these large amounts and all these other animals generation after generation, unless this large amount of vitamin C improves their health? There's no doubt that the reason that the goat and all of the other animals make these very large amounts of vitamin C is that large amounts of vitamin C are good for the health. So I accept that. That's one of the reasons that I'm taking the amount of vitamin C that I do take.
Could I ask you about, just change the subject slightly, about the use of vitamins in intelligence, as well as just your body, how they can affect and improve your mind?
Well, the brain is a remarkable organ. It's hard to believe that human beings are able to think the way that they do think, that they're conscious of their own existence and are interested in what the world was like 1,000 years or 10,000 years or 1,000,000 years ago, and that they talk about the future of the world and so on. Other animals don't do that. The brain cannot function unless there are certain important substances present in the brain. And one of these substances is vitamin C. A person who dies of scurvy will still have a good bit of vitamin C in his brain because this process of thinking is so important that we have developed methods of pumping vitamin C from the blood into the brain, even when a person is suffering from a deficiency in vitamin C. A person with scurvy will die, of infectious disease, because vitamin C is a part of the process of protection against diseases. And if you are suffering from scurvy because of not getting enough vitamin C, you have a tendency to succumb to some infection that you'd be able to overcome otherwise, or from internal bleeding, because vitamin C is needed to strengthen the blood vessels, and when you have a deficiency, the blood vessels just break open, rupture. They're not strong enough to resist the blood pressure. And still, these pumps work to pump vitamin C into the brain. So, since vitamin C is obviously required for the functioning of the brain, there's a possibility that an increased intake of vitamin C would improve the functioning of the brain. I remember 20 years ago when a couple of psychologists carried out a very interesting study in Texas with school children, several hundred school children. They measured the amount of vitamin C in their blood. And half of these school children had rather small amounts, less than 1 milligram per deciliter. The other half had more, between 1 and 1.5 milligrams per deciliter. Then they measured their IQ. And there was a 5-point difference in IQ between the high vitamin C and the low. The high ones were at 105, and the low ones average 100. Then they gave all of them some extra vitamin C, 90 milligrams of vitamin C a day for the school year or term. And at the end of that time, they took blood samples and measured the vitamin C. The high ones hadn't changed. They still were in this range 1 to 1.5. The low ones had moved up into that range. There's a physiological process that takes the vitamin C out of the blood if you get more than about 1.5 milligrams and sends it to the brain or other parts of the body. So they measured the IQ. The high ones hadn't changed. They were still at 105. The low ones had gone from 100 to 104, I think, not quite average, 105. So then summer vacation came. The students went home. You know, the difference here between these two groups of children, the psychologists tried to find the difference, the income of the family, the education of the parents, or things of that sort. There was no statistically significant difference in these quantities, but probably it was the ideas that the mother had about food that was the difference. In the one family, perhaps the children were getting orange juice or other and ate more fruits and vegetables, and in the other, the mother didn't provide these foods for the children. That may have been the reason that they, at any rate, at the end of the summer, the low ones were low again. During the summer, they weren't getting the extra vitamin C, and the level in the blood had gone down. And when they measured their IQ, it had gone down. And then they got the vitamin C again for some months, and they were up equal to, or approximately equal to, the high vitamin C group. Their vitamin C went up and their IQ. These investigators said they thought that having this extra vitamin C, not very much, 90 milligrams a day, this extra vitamin C increased their alertness and awareness, that made them a little more lively in their thinking, and that was the reason that they did better on the IQ tests. Well, there have been a number of studies of this sort, and of course this is a complicated matter. It isn't easy to carry out these studies. From my analysis of the various studies, I have reached the conclusion that in general there is an improvement, not a tremendous improvement, but an improvement in the apparent intelligence or results of the IQ tests of children if they are given some extra vitamin C per day. There's a little evidence that some of the other vitamins and minerals also, if added as supplements in the recommended amounts, have some effect of this sort.
Is there going? What do you think the maximum attainable human lifespan is? And is there going to be a leap, a quantum leap, to extend that? And if there is, how will that happen?
Well, there's a distribution curve on longevity, so that people who have reached the age of 90, only a small fraction, I'm not sure what it is, reach that age, and they have perhaps 5 years average life expectancy. When they reach, and some of them, a quarter of them perhaps, will reach the age of 100 or less than a quarter, and they have 3 or 4 years life expectancy. The maximum survival time, there's some uncertainty about it. There are stories of people living to be 150 or more, but the maximum survival time is believed now to be about 115 years. Now, I think that vitamin C can increase the average survival time by 25 years, from 75 to 100. So I would say the tail end of the distribution curve will also be shoved over by 25 years, and instead of living to be 115, that is a single person in the world's population, or the Western world, living to be 115, there will be a single person out of the 1,000 million people, say, living to be 140 years old. So that's my estimate as to the maximum survival time for human beings in the future if they all begin improving their health by taking supplementary vitamin C.
Do you think does any of your work here indicate that maybe genetically, by altering the DNA, could we live beyond the 140 possibly in the future?
Well, of course, there is a possibility that the DNA can be altered in such a way as to increase life expectancy somewhat. This means introducing an altered gene in place of a gene that's present that limits life expectancy to some extent now, or just deleting a damaging gene, removing it. Now, there are perhaps 100,000 genes in an individual's complement of DNA. That was my estimate 50 years ago, and it's the estimate that most people, most geneticists, most people working in this field make at the present time. 100,000 genes. It would be a big job to change one gene in the whole human population, or even in an individual, a big job. And if that has just an improvement of 1 in 100,000, that you may need to change 1,000 genes in order to get a really significant effect on longevity. So I'm not very optimistic about that method of increasing life expectancy. But there is a possibility that something significant can be done. My associate, Dr. Fleming, has been working on this Denham-Harman idea about free radicals by introducing a gene into a laboratory animal, in his case, the housefly, in order to see whether the gene that's introduced will have the effect of destroying free radicals faster and increasing life expectancy. Well, this, of course, is closely related to what I suggest, that you take more vitamin C in order to destroy the free radicals, more vitamin E in order to destroy the free radicals.
What about dietary restriction? Is there a theory that if you cut down the amount of food you ate, that you would live longer, because in laboratory mice, dietary restriction extends lifespan?
Well, there is some evidence that in animals, the rat especially, cutting down on the intake of food increases the length of life. In humans, we know that people who eat too much and become obese live a shorter length of time than people who have the average weight or even somewhat less than the average weight. So that just the amount of food that's eaten can determine, for some people at any rate, life expectancy. Also, there's one food that is a modern food and that is taken in large amounts and is quite harmful. This is ordinary sugar. 200 years ago, very few people could get sugar. It was very expensive. Our ancestors of 1,000 or 2,000 or 5,000 years ago didn't get very much sugar. They got a little from sweet fruits, but very little compared with the amount that people eat now. The average intake of sugar in the United States, sucrose, ordinary white sugar or brown sugar, it doesn't make any difference. It's all sugar. The ordinary person in the United States, the average person, eats 100 pounds of sugar a year. The average person in Britain eats 120 pounds of sugar per year. There's no doubt that sugar is harmful. I recommend, in my writings, I say, cut down your sugar intake to half or even less than half of the average amount. Don't add sugar to tea or coffee, and don't eat sweet desserts except occasionally. Don't eat sweet desserts regularly, and that will improve your health and increase the length of your life. So there are two ways. Don't eat so much that you become obese. Keep your weight down, and cut down on your sugar intake. I myself have since I was 40 years old, eaten a rather smaller amount of protein than most people eat. I'm not a vegetarian I'm not an ovo-lacto-vegetarian. I eat eggs and milk quite a bit, eggs and milk, but I also eat meat occasionally, but I don't eat a large amount of meat. My protein intake is not much more than the amount that I need to replenish the proteins in my body. In my case, that's 40 grams a day, about 1.5 ounces of protein a day. Most people eat 2 or 3 times or 4 times that amount of protein. So it is possible to improve one's health by dietary methods. I don't recommend going on crash diets to get thin, and then when you're off the diet, eating a lot so you then become fat again. There's evidence that this zigzag method of controlling the weight is really harmful. You have to limit your intake of food. If you have a tendency to obesity, you have to keep your intake of food down in a steady manner, day after day after day.
Great type, Gary. Could I ask you, sir, to tell us how old you are and how long do you hope to live?
You know, I was born in Portland, Oregon, and then moved to a small town in eastern Oregon, Condon, Oregon, population about 500 then and population about 500 now. And I was born on the 28th of February, 1901. So now, in 1991, I'm 90 years old. I can't predict how long I'm going to live. I'm in pretty good shape with respect to my general health. Nothing to complain about. I'm not so steady on my pins as I used to be. I don't run very much. I avoid running. And I suppose my muscular strength is decreased with passage of time. But I don't have any disease at the present time. The statistics suggest that if I'm an average person, I'd live 5 years longer. I don't think I'm an average person because I take so much more vitamin C and other vitamins than the average person takes. So I would say I have a probable life expectancy of 10 years now, but if I'm far enough out on this distribution curve, I may well live even longer than that.
Thank you very much. Excellent. Thank you very much. Kat?
That was a piece of equipment that it is, has the ability to convert vitamin C into other chemicals that the body may require and is not getting an adequate supply. Is there any truth to that?
Oh, yes. Yes, there is.
Well, I'll ask the question then because of my yeah.
Yeah, I'm rolling.
Could you tell me how vitamin C also makes other nutrients and vitamins?
Well, I mentioned that 20 years ago I measured the amount of vitamin C that I was excreting in my urine when I was taking 10 grams a day. And I was losing only 1.5 grams in my urine. Well, I was taking this 10 grams by mouth. Some of it didn't get into the bloodstream but stayed in the intestinal contents. And it wasn't really wasted. It was protecting my lower bowel against cancer of the colon and rectum, so it wasn't wasted. And I'm not sure how much, about half of what I ingested, or perhaps 60%, got into the bloodstream. But only 1.5 grams was eliminated in the urine. So I thought, what happens to the rest of it? It must be changed into certain oxidation products of vitamin C. In fact, we got evidence 18 years ago, that if you take large doses of vitamin C, the body responds by developing a procedure for converting the vitamin C into these other substances, a procedure that it didn't have operating before because there wasn't enough vitamin C being ingested in the food to allow any of it to be converted into other substances. So we have for 18 years been studying in our institute the value of these other substances that you get in your body if you take a large amount of vitamin C regularly, but don't get in the body if you don't. One thing that's been found is that these substances are more effective against protecting the body against cancer, which is what we've been studying, than vitamin C itself. So one reason for taking large doses of vitamin C is that the body responds by converting some of the vitamin C, a large part of it in fact, into other substances that are valuable for the health.
Go tighter. Could you define what these other substances are?
Well, I could...
Very briefly.
You know, I'm a chemist. There are about 10 million chemical substances that have been described in the scientific literature, and I know the names of a lot of them, and I could give chemical names. But we do know that these substances are oxidation products of vitamin C. They are similar to vitamin C, but not exactly the same. They've had some more oxygen atoms added. There hasn't been enough work carried out as yet to permit me to say what the mode of the mechanism of action of these other substances in improving the health of human beings is. We've carried out some studies to check what these other substances do, but to determine the molecular mechanisms is a hard job that we haven't succeeded in tackling successfully as yet.
Okay, lovely cut. It was excellent. Thank you very much, sir.
That's great. Okay.
Right.
Super.
If we
Great
could,
interview.
right, it was very, very good. I wonder if we could put you at your desk now,
Surely.
and I'll take the mic off, and just as if